Hello my friend, are you a mathematics teacher or a mathematics teacher educator? You might as well be a mathematics teacher trainer or a professor of mathematics. That is one question. How do you take maths? Is math a difficult subject or is it easy to learn? Is mathematics dry and tough to learn or it is joyful and fun to learn? So your answer could be anything. But anyway, we still have to cope with the fact that many students dislike mathematics. My view to useful mathematics is that it should be interesting, motivational, joyful and fun to learn. But it's not so. Why? Many students dislike mathematics. We made math difficult. We as the curriculum planner, the textbook writer, teacher trainer or a teacher, we have made mathematics difficult. The reason for this is because the textbooks are difficult, the method of teaching is difficult, the way how the ideas are delivered are not motivational to the students. Let's imagine for a while. Can we imagine a mathematics book where figure dance? If the books were so, perhaps students might have enjoyed dancing in the book of mathematics, and mathematics would have been easy for them. Unfortunately, math is too dry and abstract. My approach in demystify maths is to help students learn mathematics in a joyful manner. I have given my ideas in the book in depth. Here I am talking about addition of series of books that supplement learning ideas in demystifying maths. Why I am talking about demystifying maths, I am talking about the book which I have written entitled Demystifying Maths. One of such supplement book might be My Big Book of Angles. My Big Book of Angles. Let's start with the student's question. What is an angle? The student may ask us. Our answer might be, an angle is the separation between two lines. We are correct, absolutely, my friend. And now the student may ask, what is a line? We may answer, a line is a set of points in a fixed direction. That's correct. Again, the student may ask, what is the point, sir? And our answer might be, a point is undefined. And the student would be surprised. Sir, how did you define a line with undefined elements? Now we have gone to very abstract thinking, my friend. It makes mathematics tough and difficult for the student to learn. So instead of that, my big book of angle, which is supposed to be supplement to demystify maths, introduces angle somehow in different way. So let's see how it does. In the beginning, to the beginner it says, when you go on holding something, your arm traces angle of different sides. And what about your legs? When you go on walking, what do your legs represent? Do they represent angle? So your physical movement at different position. Also, when you move with certain angles. Similarly, the hands of the clock move through certain angles at different times. At the same time, you may open the door with certain angle. And if you have the book also opens with certain angles. Actually, now what you are doing, you are helping students to represent angles physically. You are helping students to touch and feel mathematics. They can touch, they can feel, they can see, and they can experience maths. So this is a book which I imagine. Can you imagine the book where figure dance? Actually, if you go here, is not this dancing? That type of thing is possible. And similarly, you can go angle may be smaller or angle may be bigger. So the smaller and bigger angle, you can give the physical example with the scissor in the book itself. And you can measure the size of the angle using the protractor. While you use the protractor, you can use the inner scale and outer scale. So when to use the inner scale and the outer scale, the book clearly gives you the situation here. with the real protractor fixed into it. And after that, the student may be given the angle and the smaller or the bigger angles over here, and they may go now using the set square, the acute angle less than 90 degree, right angle exactly equal to 90 degree, obtuse angle greater than 90 degree. Similar thing can be done using the grid. At each point in the grid, you can see 90 degree. That's why the grid may be the reference for that one. And similarly, angle may be of different kind. They may be appearing in pairs like that, and they may make the linear pair, or they may make the pair of angles getting up to 90 degrees. And angle may be when two lines intersect, there may be the vertically opposite angles in different sides, and student can realize vertically opposite angles are equal, and after that they can be engaged in certain written work over here. And then they may go to the pair of angles made by the transversal when they intersect pair of lines. For example, there are different angles, this is the transversal and these are the lines. But there may be situation when two lines are parallel, and when two lines are parallel, alternate angles have the z set, and with the pivoting system you can easily demonstrate that they are equal. And that type of facility can be made available in the book itself. Similarly, the pair of corresponding angles are found in the shape of f, and these f-shape angles, they are equal to each other. You can demonstrate this by sliding the f-shape down, and now you can see that angle is fitting over there. Similarly, you can slide it up and demonstrate that the corresponding angles are equal, like this. These two angles are equal to each other. And likewise, the co-interior angles are in the shape of C, and they add up to 108 degrees. If you slide it down, it goes and these two angles make the linear pair. When they make the linear pair, the angles are adding up to 108 degrees. So this way, the very elementary ideas in the junior classes should be introduced this way. We can introduce it this way, and we may go to the abstract thinking, proving the theorems in senior school. The alternate angles, the corresponding angles, and the co-interior angles, and the relation between them could be verified this way. And that type of material could be made available within the book itself, and this is nothing but the supplement to the demystify math. And demystify math gives in depth the detailed idea how to make all these things and how to use them in classroom situation. That does not give the material. Ask the teacher to work with that one, and this gives the material to the teacher. So that way we can have a similar, similar reference, additional resource could be the Talk to Me triangle. It is the biography of triangle written in 2 volumes, Talk to Me Triangle 1 and Talk to Me Triangle volume number 2. There are 2 different volumes. And I am going to demonstrate one example from here. Just have a look at this. It is talking about the going round about the triangle. Definitely it is talking something about the perimeter. What is it? The perimeter is the total length of sides of the triangle. How can a student verify this thing? It's just fun. It can be done by measurement, no doubt, but this is the scale over here, and the triangle rotates at certain angles. And this is 8 centimeter, 10 and 8 makes 18 altogether. And lastly, we are measuring the remaining side, and that side is, it goes there, that way. It is altogether 25 centimeters. So this type of handle activities are the enrichment activities that motivate the student to learn and do something through the motivation of the teacher, through their own motivation, through their involvement in different activities. And Talk to Me triangle, another example. I am taking another example from the book. Here is a triangle. The purpose is to find the area of the triangle. How do you do it? Actually, this goes down there, it's the teaching aid, and that goes down there. And now it is the rectangle. I do the length equal to the base of the triangle, and breadth equal to the half height of the triangle. And then ultimately the area is length into breadth, and length is the base of the triangle, and breadth is half of the height of the triangle. And ultimately it gives you area equals half base into height. So my approach throughout the supplementary book is like this, to make the teaching aid available within the book itself. Similarly, the other resources with me, my big book of symmetrical pockets, my big book of elementary paper folding techniques, my big book of multiples, and I have some mathematics charts as well. Charts are the ready-made material, and these are the dummy printout, and this can be printed in very big charts and posters, and they aid as the teaching resources which can be brought into the class and demonstrated for certain concepts. A student at a glance can see what concept they are delivering, what they need to know, and that type of things would be easily visualized using the chart and posters. I have the chart ready to print status like this. And now, my dear friend, let me take time for some time to help the student learn through manipulators with whom they can play. Our objective again is to find the area of this triangle. Area of this triangle. Now you take out this part. You can take it out and you fit it over there. It fits exactly, and take that part and it fits exactly over there. Now you have two triangles. One is this, the next one is over there. That is why the whole figure is the rectangle which has the area double of the triangle. You should know the area of the triangle is length times breadth, and they take half for the area of the triangle. Same thing can be done by another technique. This is a triangle of which we are going to find the area, and for that one we take the three angles together at a point like this. Now it is somehow the different concept by a different way. Now the area of the rectangle is half of the triangle. Previously we have used area of the rectangle is double of the triangle. Now the area of the rectangle is half of the triangle, and is length into breadth. Length is half of the base of the triangle. Height is also, breadth is also half of the height of the triangle. And multiplied together, it becomes 1/4 base into height. And two such will make the whole triangle. That is why multiply by 2 gives us area of the triangle equals half base into height. So this is another alternative for that one, and demystify maths gives several alternatives like this. The another easiest way is this again. You take out that one and fit it over there, and take other part and fit it over there. Now again you have the rectangle. The area of the rectangle is very much easy and transparent to the student. Similarly, the one which we have seen in the book, my big book of triangle, the area of this triangle can be worked out like this. Again you have the triangle, this one and this one. These two are the most similar thing. And this type of thing can be produced industrially by the educational material industry also. And all different kinds of triangle, they fold either into the rectangle or into the parallelogram like that. Now the area of the triangle is equal to the area of the parallelogram, and the area of the parallelogram is base into height, and base is this, height is half of the height of this triangle. So this way, and and if it is the oblique triangle, and again it goes into the parallelogram like this. That's why the area could be transferred either into the rectangle or into the parallelogram. We have the huge pile of mathematics material that can be used into classroom teaching. Students can play with these materials and make mathematics class fun and interesting. So in your maths,